Hello everyone, this is Maniepa and I'm right here in one of those old classes about to do this paper, August 9, 2022, Science Paper 2, Section A. This was a GCE paper. Let's get to Section A. So as you know, in this paper you are supposed to write from within the paper, and this is how your answer sheet appears like. You've got 20 questions in Section A. You indicate your exam numbers there, and then you answer from here, but the questions are right here, so you answer from within the paper. But I answered from the questions so that you can easily just see the answer and the question at the same time. So Section A, question 1. The branch of chemistry that deals with the identification of composition of substances is analytical chemistry. From the name you can tell, say it has something to do with analysis. Inorganic, no. Organic, no. Physical, no. The answer there is A, analytical chemistry. A2, the following diagrams show the arrangement of particles in a substance under normal atmospheric pressure but at two different temperatures. Look at this regular arrangement. This is not regular. This should be gaseous. Temperature -125. This is -90 Celsius or centigrade. Which substance could the diagrams represent? My take was D. Okay, because 125 is less than 115. Okay, -125 is less than 115. So this is regular arrangement showing that the substance is solid. So the only sensible melting point that can be there is 115 and 120. But when you look at the boiling point of this substance, the one which makes sense is 92, because 92 is greater than 90. Okay, -90 is less than -92. This is greater than that, so it cannot be gas. In short, the one that makes sense is 92, because the boiling point, or the point at which by the time the substance is at 90, it would have already evaporated at 92. Okay, so remember, 92 is actually greater than 90 because you're going towards the zero. When you're counting in minus, the smaller the appearance of the figure, the greater it is, because you're going towards zero. It's like you're counting backwards. So if at 90 it's a gas, it means if you go to 92, it means the temperature is becoming lower. It means the boiling point is likely to have been at 92, not 88. Hopefully you are able to count using a number line. The answer there is D. My third question, that the following diagram shows part of the laboratory thermometer. You've got the scale there, 20, 30, then you've got this division here. What is the temperature shown in the centigrades, in degrees Celsius? My take was 28.0. You look at this is 20, 21, 22, 23, 24, 25, 26, 27, 28. Okay, so you just have to be familiar with the scale and how it's written there. That is 28 degrees Celsius. Answer is C. My next question there is A4. The following table lists the data obtained in titration experiment. Which reading should not be included to compute the average volume of the acid in the titration? You have to round off these figures. Okay, you repeat volumes of the titrant. As let me say you run the titration more than once to increase your degree of accuracy, and then you simply check your values of the volume used, and you'll be able to tell which one where you could have used too much, or you can be able to tell the range. So when you round off all of these, it'll give you 13. This will be 13, this will be 13, but this one will be 12. So the answer there is D. The answer is D, because it's after rounding off, it's a little bit far away, meaning maybe in this experiment you closed off the acid too soon, so you used less than you recorded. But these others are able to tell you that you were almost there, you were almost there, because it's difficult to be exact when you're dealing with drops, volumes, solutions, just by looking. Number A5, the following diagram shows the chromatogram obtained when a sample V was analyzed together with 4 other known dyes, W, X, Y, Z. Dye X known to be poisonous. Dye X was known to be poisonous. Which of the following dyes are safe for use? I don't know if it's skin use or use in terms of eating. But the thing is, my answer was Z only was safe, because when you look at Z, it doesn't have any X in it. When you look at X, which is poisonous, after the whole dissolving, look at its chromatogram, it's right here. Chromatograms can be used to tell if something is pure. Therefore, any soluble substance has got its own solubility rate. It's like the boiling point. Every pure substance has got its own boiling point and melting point, which should be sharp. So when it comes to chromatography, the rate of dissolving is something that is key to tell if something is pure. So X dissolves up to this point. And if you have any other components in these other substances which are also up to this level, it means they have a component of X in them, so it means they're all not safe apart from Z. Apart from chromatography, boiling point, melting point, sometimes purity can also be determined by observing the flame, the color of the flame. If when it comes to flammable substances, every pure substance, when it comes to flammable substances, has got its own color of flame. So my answer there was D. You get to 6. The following diagram shows the structure of an atom. Okay, so that's our nucleus. Those are the electrons in their orbitals or shells. What is the proton number and nucleon number of the atom? Proton number is self-explaining, the number of protons. The nucleon represents the number of protons and neutrons in the atom. So nucleon just means the particle that makes up the nucleus. So proton number, you check 1, 2, 3. There are 3 between these two. Nucleon, you count all of them. 3 plus 4, because these are 3, then this 4 plus the 3 gives you 7. Our answer is B. Okay, our answer is B. Next question 7. Lithium occurs in a mixture of two substances. Lithium, look at me. Lithium occurs as a mixture of two stable isotopes. Okay, two stable isotopes. That is lithium 6 and lithium 7. Remember, isotopes are called by their mass because they only differ in mass, not in the number of protons. The protons are the same, 3, 3, but the mass is different, or the neutrons are different. So there is lithium 6 and lithium 7. The relative atomic mass of lithium is, you have to calculate to find the average atomic mass of lithium. So average atomic mass is equal to the mass of the isotope times its percentage composition out of a natural sample, plus the mass of the next isotope times its percentage composition, plus if there are 3 of them, you simply add you keep on adding and then divided by 100. So my answer was 6.9, and it comes out as 6.9. Usually on these common periodic tables on the school, the high school ones, we usually use 7 because it's rounded off. I think on our periodic table, the only element that has got a decimal on its mass is chlorine, but most of them are rounded off. And that doesn't mean they're not decimals. That doesn't mean they're not average atomic masses. Most of them are average. 8. Magnesium forms an ion with a 2 plus and then a cation with a 2 plus charge there. The number of electrons in the magnesium ion is, you have to check from the periodic table. Okay, magnesium, the magnesium nuclide is Mg, okay, 24, then 12. The mass is 24, the atomic number is 12. Therefore, in a neutral magnesium atom, there are 12 electrons. There are 12 electrons. So if it forms an ion with 2 plus, it means it has lost 2 electrons, and this shows that there are 2 protons whose charge is not shielded or is not neutralized by the negative from the 2 electrons lost. Therefore, the positivity of the 2 excess protons whose charge is not neutralized or cancelled is shown here as 2 plus, meaning it has got 2 extra charges. So it means that it has lost 2 electrons. Therefore, 12 minus 2 will give us 10. Okay, to give us 10. Our answer there is B. Number 9, move the paper a little bit. Number 9, which element exists as monoatomic molecules at room temperature and pressure? These are noble gases. They exist as atoms. Okay, atoms. Most of these non-noble gases exist as diatomic molecules, even like ozone, which is highly unstable, but it's the noble gases: helium, argon, and neon. Here fluorine is F2, this is O2, This is actually H2. So the answer there is A. That comes from the topic of periodic table, the periodic table topic. Number 10, deduce the formula of lead 2 phosphate. Okay, lead 2 phosphate. You have to know how the phosphate ion is written, or the formula of the phosphate ion. Lead 2, this shows you that the lead has a 2 plus. This tells you the oxidation state of the lead ion. So remember, the valency of an ion can be extracted or concluded from the charge on it. The valence here is 2, the valence here is 3 because the charge is minus 3. So the charge on a given ion tells you the valency of that ion. So in formula writing, you just swap the valencies when you're trying to form or maybe predict the formula of simple compounds like these. So you just swap the valencies. This 3 comes this side, it becomes a ratio of Pb or lead, and the 2 goes to the other side and becomes an atomic ratio or species ratio of the phosphate ions in the compound to be formed. Therefore, in the compound that is formed when the 2 react, the neutral compound that will be formed will need 3 Pb atoms and 2 phosphate groups. Okay, 2 phosphate groups. So our answer comes out as C. Valency is the key thing here. And also remembering the charges and the species that are involved in there. So number 11, which one of the following substances dissolves in water to form a solution with pH of less than 7, therefore acidic pH? Ammonia, no, it forms a base. It forms an alkali, a weak alkaline solution. Sodium chloride, this is a neutral salt. So when we talk about pH, we're talking about finishing or release of either hydroxyl or protons, hydroxyl group OH, or protons into an aqueous solution once that given substance is dissolved. So this one will not produce any hydroxyl or protons. This one will not do the same, but this one will actually form a weak solution of ammonium hydroxide. But this guy here, sulfur dioxide, this guy, which is commonly released when sulfur containing compounds burn, it dissolves in water to form a weak solution of sulfurous acid. Therefore our answer there is D, sulfur dioxide. You cannot say sulfur trioxide. Sulfur trioxide is highly unstable, so it has to be made and fixed to form sulfuric. This is sulfurous. So the case of sulfur trioxide is something else, but this one, yeah, it would easily dissolve in water to form a weak acid. Not a weak, but a dilute acid. A12, dilute sulfuric acid reacts with both magnesium oxide and magnesium carbonate. How are these two reactions alike? Okay. Before I could answer this question, I was made to write these equations. That's sulfuric, magnesium oxide, magnesium carbonate. The products are having magnesium sulfate, a salt. There's water. Here there's also carbon dioxide. So they are similar in the salt and the production of water, which is, I would say, some kind of neutralization effect on the nature of the acid. So water is produced. That's the main thing. Hydrogen, no. Carbon dioxide, only one has carbon dioxide here. White precipitate, let me just say water is formed, is our answer there. Crystals of sodium carbonate decahydrate, deca means 10, hydrate 10 water, are efflorescent. Okay, when these crystals are exposed to air, the crystals, they want you to finish the statement. Before we even look at these answers, allow me to just explain or maybe look at the other terms that are close to the term efflorescent. Before I even look at these terms, allow me to get back to these salts that are hydrated. Are simply those salts which have water as part of their crystal lattice. An example is the same, copper 2 sulfate, sodium carbonate. They do have water in their crystal structures or lattices that which enables them or helps them maintain their crystalline nature. This water in these hydrated salts or hydrated crystal salts can be lost when you heat the salt or in an oven or openly. Therefore, once the water evaporates, the salt will lose its crystalline nature or structure or lattice, and it will become amorphous or powder. So we get back to this. Efflorescent means a salt which loses water, okay, when exposed to the environment, and simply once it loses its water, it also loses its crystalline nature. It becomes a powder or amorphous. Deliquescent is another term that is close to efflorescent, which are usually used close to each other to define the nature of these salts. A deliquescent salt gains water from the atmosphere, surrounding atmosphere, and dissolves in the water to become or to form a solution. You put this salt on a table, on a piece of glass, it will actually absorb water, moisture, or water vapor from the atmosphere, and then it will absorb a lot of water vapor to the point where it will form a solution, a drop of water or solution. It will dissolve in the water that it absorbs. That's the key thing. Then hygroscopic salts simply gain water and become damp, like sodium chloride. They will just become damp and not dissolve in the water that they have absorbed. So we come back to this. Efflorescent salts lose water. Okay, they lose water from their crystal structures to become powders. So we go to the question again. When these crystals are exposed to air, the crystals lose mass and remain solid. Yes, they will lose part of their water, meaning they will lose mass, and they will remain solid. Although here it's not complete, they will remain solid, not in their crystal nature. They will just become powder, but solid. Okay, so the answer there is C. They won't gain mass. Here, change liquid and evolve bubbles. No, it is just C. This is complicating issues when you go to D. The answer there is C. So remember these three terms. They are closely related, and you can easily swap their meanings. Number 14. 1 mole of nitrogen and 1 mole of ammonia gas have equal number of molecules. 1 mole. That means that a substance which is quantified as 1 mole means that it is having particles or basic particles that are 6.022 times 10 to the power 23 particles in itself. Okay, this is Avogadro's number or constant. So if it's 1 mole, then it's this number. So whether it's oxygen, it's what? The moment you just say 1 mole, it means equal number of molecules. The answer there is C. Number 15. A solution of calcium chloride contains 11.1 grams of salt in that much liquid or solution. What is the concentration of the solution in moles per decimeter? Concentration can be calculated in grams per decimeter or moles per decimeter. So this is for the formula. This formula is for moles per decimeter or per volume. The volume always has to be in decimeters. 1 decimeter is equals to 1 liter. So I have to convert this one to moles so that I can plug it here, and then I just convert these cubic centimeters to decimeters by dividing by 1000. It gives me 0.25 decimeters, and then I have to you have to know the formula for calcium chloride for you to find the mass or the molar mass. So calcium chloride, that's the formula. Calcium from the periodic table has a mass of 40. Then chlorine, that is 35.5 times 2, because there are 2 of them, to give you 111 grams per mole. That's the molar mass of this salt. So to find the number of moles is equals to mass over molar mass. Then the answer comes out as 0.1 moles. So this 11.1 grams is actually, in moles, it's 0.1 or 0.1 moles. And then I get this 0.1 moles. I plug it here where the moles are. Then I get my volume, converted volume. I plug it there. It gives me 0.25 decimeters. When I do my division, it gives me 0.4 molar. Okay, 0.4 molar is the same as saying moles per decimeter. 0.4 molar is the same as saying moles per decimeter. If you are using grams up here, you cannot write molar here. You have to write grams per decimeter. But if you're using moles per decimeter or per volume, you can write molar. So our answer here is 0.4. 0.4. Number 16. When an excess of magnesium powder was reacted with dilute hydrochloric acid, the reaction was fast at first but gradually became slower and finally stopped. Which of the following best explains why this happened? The hydrochloric acid was used up. That was my take. Look at the question again. When an excess of magnesium powder, meaning the powder was in excess reagent. The limiting reagent is the limited reagent. Okay, the limiting reagent is the limited reagent in terms of quantity. It is the reactant that is in limited supply. It is the reactant that determines the amount of product that is going to be formed. It's a reactant that finishes first in a chemical reaction. So if this reaction came to a stop, it means it wasn't the magnesium powder which was less, it's the acid, because the powder was in excess. So my answer there was A, hydrochloric acid was used up. 17, what could be the chemical formula of the nitrate? Let me go again. What could be the chemical formula of the nitrate of an element Q of group 3 of the periodic table? Group 3, this tells you that this element is in group 3, it's a metal, its valency is 3, because provided the valency is 4 or less, then the group number is equivalent to the valency of that element when it comes to simple valency. So 3 means that the valency is 3. The nitrate has a valency of 1. The nitrate has a valency of 1 because it's minus 1. So when you swap the 2, there's a 1 here, then there's a 3 there. The formula comes out as D. Formula writing comes out as D. Number 18, some metal ores are roasted in air before they are reduced in the blast furnace. What is the main air pollution caused by this process? Okay, some metal ores are roasted in air before they are reduced in the blast furnace. Look at the question. It's coming to you in some kind of two-stage thing where the metal has to be roasted in air, but again it still has to be reduced in the furnace, meaning some kind of roasting goes on or keeps on, the next stage of roasting, but this next stage of roasting is referred to as reduced. Okay, so the case where a metal ore is roasted in air is simply a case where the metal ore is being converted to an oxide. And most of these metal ores are usually sulfides, like copper sulfide, zinc sulfide, zinc blend, and the like. So once you roast a metal in oxygen, you are causing it, or you are making it react with oxygen. In other words, you're oxidizing it for it to become an oxide. And then through the process, sulfur dioxide is released, and the metal becomes an oxide. Later on, this metal oxide is put in the blast furnace where the metal is displaced from oxygen. It's displaced by carbon. This is called reduction. Therefore, the oxygen is removed from the metal. This is called reduction, and then it remains as a metal, and then the oxygen goes to carbon to form carbon dioxide, which is again usually released into the atmosphere or contained for other purposes. But the thing is, we call that reduction, or the metal ore is said to be reduced. So sulfur dioxide is produced. Okay, sulfur dioxide is produced. Our answer there is D. Our second last question there is, the following structures represent different types of soap. Which statement about soap is correct? Soap is a salt. Okay, it's a salt. This is a carboxylic acid component, and then there's a metal there. Okay, there's a metal there. And when is the salt formed? When all or part of the replaceable hydrogens in an acid are replaced by a metal or ammonium ion. Therefore, the acidic hydrogen is the one that is on the OH when it comes to carboxylic acids. The other hydrogens are not acidic. So this acid here has been replaced by a metal ion. So whatever results is a salt. The answer there is D. Read about saponification. 20, the question reads, what would be the structure of the polymer formed when the following monomers undergo polymerization? So we've got a carboxylic acid there, then we've got an alcohol, double alcohol, diol, or diol. This is a double carboxylic acid, okay, dicarboxylic acid. So when you look at these structures from above here, look at the monomers, look at the central part of the monomers. They seem to be like they're of the same length or the same composition at their centers. I would maybe pick an example. Maybe this is okay. Let me not complicate things. But look at their similarities there. if these were to bond, it can't be A. There is no amino group here. There are no amino groups. There's just a carboxylic group and the alcohol. 2 or B, there are no amino groups in those monomers. Ammonia, there's no nitrogen in those monomers. C, look at the difference in the central part of the, okay, this means that the central part of these molecules are different, but these are the same. So even the polymer has to be something like this. Okay, so the answer there comes out as D. This marks the end of our section A of this paper. I'll meet you in the other section as I make another video. Have a good day, and remember, for the love of science, we do these things and go up to the end. Study these things, and later on they'll help you.